Hello everybody, this is the next video in the series of videos on Python programming for engineers. My name is Mark Bakker and I work at the Delft University of Technology. Today's topic is creating interactive graphics using matplotlib widgets. We will start with adding radio buttons to a graph. The process of adding widgets to a graph is always the same. You first create an axis, you add a graph. Then you create a second axis where you're going to put your widget. You add your widget to the axis. And then you tell the widget what function to call when its state is changed. For example, when the radio button is pushed. All this requires the use of matplotlib's object-oriented features. We will start with making a graph, and the example we'll do is for a sine of time. The sine of 2 times pi times time times some frequency n. Let me show you how that works. First we create a figure. Fig is equal to figure, and we give it the figure size of 8 by 8 inches. There's our figure. Selected that size so that it nicely fits on this screen. And we're going to add an axis to that, we say, and we store that axis in the variable ax. X is equal to fig.add axes. And the axes add axis function takes 4 arguments, or takes a list with 4 arguments: the x and y of the lower left hand corner, the width of the axis, and the height. And they're all on relative coordinates. So we start at point 3 of the x-axis and point 4 of the y-axis. The width is 0.6 and the height is 0.5. Now you see I entered that, but I don't see anything yet. Why is that? Well, in the object-oriented interface of matplotlib, the figure is not drawn until you tell it to draw. So to tell it to draw, we have the function draw. There it is. That's the axis we just created. Let's add a line to that for a sine function, where x goes from linspace from 0 to 1 with 100 points. Well, let's do 200 points, get a nice graph. We take the frequency to be 1, and y is equal to the sine of 2 times n times pi times x. We create a line, and we're going to call that line with the line2d class, line2d, which takes the x values and the y values of the line, and we add the line to the axes. X.add line. Again, we don't see anything until we call draw, and there's our line. Wait a minute, that doesn't look quite right yet, because we expect it to be a nice wiggle, because the sine goes from 0 to 2 pi when x goes from 0 to 1. Why is that? Well, in the object-oriented interface of matplotlib, it doesn't automatically adjust the limits on the axes. Sure, x goes from 0 to 1, that is still correct, that's the default value, but y should go from -1 to +1. So we set x.set ylim to go from -1 to 1. We call draw again. And by golly, there it is. Now we can change n. We can say n is equal to 5. We calculate new y values. And now we have to change the y values of this line. The line is called line. And we say set y data. And we change it to these new y values. We call draw. And there is our changed line. Now here I changed n by just typing a new number, calculating y, changing the y data and calling draw. What I want to do is here on the graph, I want to make a few radio buttons. Buttons you can click for different n's. To do that, we first have to add a new axis to the graph. And we're going to call that axis 2. ax2 is equal to fig dot. We're going to add an axis to the figure. Again, with relative coordinates, we go 0.05 of the width of the figure and 0.5 in the y direction, so we're halfway up, and the figure is 0.2 by 0.2 of the figure size in width and height. That's called axis 2, and we're going to give it a title. You can give it a title right here, so it nicely prints a title above the new axis that comes, and this is going to be called the frequency. We call draw, so we know where we're at. There is our new axis. It doesn't look very good yet, but we're going to add radio buttons to that. To add radio buttons, we first have to import the radio buttons object from matplotlib.widget, import radio buttons. And we're going to create a radio button. Radio is equal to radio buttons. We open the parenthesis, and it tells us it needs an axis to add the radio buttons to, and that's our x2 that we created just for that. And it requires some labels, and then there's some optional things. And the labels are the different values or the different labels you want to have. Let's add the radio buttons to axis 2, and for the labels we say, well, n can have the value 1, maybe the value 2, and the value 5. You can put as many as you wish. Let's make 3 buttons. And we can call draw again. I'm only really calling the draw intermediately to show you what I have changed. Normally when you do this, you type everything in before you call draw. But let's do it. There we go. Nice. We have radio buttons and you can click them. See, and they change in color. But it doesn't quite do what we want yet because it doesn't change anything to the graph. Why not? Well, we haven't told it how to do that. We need what's called an update function. And that function we're going to write is called def. Well, it's a function, so it's called def. Let's call it set frequency. We can call it anything we want. And it's going to get the label of the radio button that we have clicked here. Inside that function, what do we need to do? Well, that label indicates the n, the frequency we want to set. So we say n is equal to label. But remember, label is a string. They are given right here. And it needs to be a number. So we have to convert the string to a floating point number. So a float of string of the label, which is a string. We calculate our new y value, which was sine of 2 times n times pi times x. We change the y data of our line.set y data y. And then we want to call draw, because then we really do want to update the function. So that's the function we want to call when we click on a button here. Now how do we tell the radio buttons to call this function? The radio buttons we called radio. We could have called them anything. We decided to call them radio. And we say radio.onClicked. That's a function of the radio buttons. It tells us when it's clicked. So on click, we're going to call the function setFreq. Now let's see if it works. If you now push 2, it makes n2 and it updates the figure. When I click 5, it makes our frequency 5. I click 1, it makes it 1. It seems like we got it to work. Next, I want to talk about a different type of widget called a slider. A slider lets you, well, slide to change the value. I recreated the figure of the sign we used in the previous example. I created the figure, I added an axis to the figure, I set x going from 0 to 1 with 200 steps, I set the frequency n is equal to 1, y is equal to the sine of 2n pi x. I created a line with the line2d class where I specify the x and y values of the line, I add the line to the axis, and I set the y limits of the axis. Then I call draw, and I get the figure we had previously. Now I'm going to add a new axis where we will add the slider 2. And we're going to call it x2 again. Is equal to fig.add axes. And we're going to position it right under the current axis. So the lower left-hand corner is 0.3, 0.2. The relative coordinates of the xy of the lower left-hand corner, it's 0.6 wide, just like the current axes are, and only 0.1 high. And if I call draw now, there is our axis number 2. And I want to add a slider to that axis. First we have to import the slider class from matplotlib.widgets import slider. We're going to create a slider. We have to give it a name. Let's call it freak, for example. Yeah, let's call it freak. Is a slider, open parenthesis. It tells us what it needs. It needs, if you can just barely see it here, it needs an axis that we are going to add to. We're going to need the label, and in this case that's the name of the slider. It needs the minimum value of the slider, the maximum value, and then some keyword arguments, for example, the initial value. And we're going to use that. So the axis we're going to add to is AX2. The label is called frequency. So that's really a title, would have been a better name. The minimum value is 0.5, so n can be 0.5. The maximum value of n is 5, and the initial value is 1. And I call draw. There's our slider, you see, and we can slide it. And on the left hand side we see here the name we gave it, that was that label. Here we see the value that it has, it's now at 2.81, but just like for the radio buttons, you see it doesn't change anything in the graph yet until we start changing it. So let's do that. We have to write a new function, def set frequency, just like we had before, but it will now get past the value of the slider, val, so it's not the label of a radio button, it gets past the value of the slider. And we say n is equal to the value, just like before, but now the value is actually a number already, so we don't have to convert it to a number, it is already a number. We recalculate y is equal to the sine of 2 times n times pi times x. We change the y values of the line.set y data with y, and we call a draw. Then we finally tell the slider, which we called freq for freak, dot on changed is the function name. When the slider is changed, the set freak function is called. And now we can start changing it, and if you're lucky, you see it nicely changes all the way to 5, and we can go all the way back to 0.5. There is your slider. That's all I had for you today. I hope to see you next time.